And now we go on to Oral 10, Pleasanton and Callaway, Nebraska. This is a Mission 3B flight experiment.
Good afternoon. My name is Brianne Zimmer.
And I'm Kara Dowell.
And we are proud to represent Pleasanton Callaway from Nebraska. Using the past to guide the future, when we first began our mission to Mars, we were challenged to learn from adventures of the past by asking the question, what concerns do we have for traveling into unknown territory? For example, the travelers on the Oregon Trail faced many hardships that they had to prepare for before they began their journey. As a group, we identified the challenges that faced early travelers. These concerns included food preservation, health and wellness, dealing with illnesses, and transportation. Next slide, please.
For early travelers on the Oregon Trail, the plains of Nebraska probably ignited feelings similar to those we have about Mars today. The territory was vast, unknown, and yet held a world of possibilities. Thinking about early travelers helped us frame our question for future travelers to Mars. Next slide, please.
We need to anticipate the problems of the future of space expeditions like those who traveled the Oregon Trail. How will we get there? What will we eat? And what will be the impact on overall health as we travel? After asking these questions, we settled on the topic of health and wellness. Next slide, please.
As we began to explore health and wellness in microgravity, we came across an article submitted by Kidney International, which reported a higher incidence of kidney stones for astronauts. We began to wonder if microgravity had an impact on kidney stone growth. Thus, we formed our hypothesis. Kidney stones form differently in microgravity. Next slide, please.
After formulating our hypothesis, the next step was to research how to replicate kidney stones in a lab environment. We teamed up with Dr. Frank Kovacs, Associate Professor of Chemistry at the University of Nebraska at Kearney. Through our collaborative investigation, we came up with our solutions in order to create our kidney stones. To replicate kidney stone chemical composition, we used the solutions of calcium chloride and oxalic acid. In order to keep the two solutions separated until in microgravity, we used the FME tube type 3. In volume 1, we put our double distilled water calcium chloride solution. In volume 2, we put double distilled water oxalic acid solution. And in volume 3, we filled with air. Next slide, please.
After a few trials and errors, our experiment was prepared to blast off. This is a mission patch that represented Pleasanton High School in space. It was drawn by Jasmine Tappy, an 8th grader at PHS. The image is of a Falcon, inspired by the name given to the Mission 3 payload, the Falcon payload. Next slide, please.
After examining the images under a microscope at 600 times magnification, we found noticeable differences between those formed in microgravity and those formed on Earth. Image number 1 shows the crystals grown on Earth and are fully polarized to show the crystalline structure. Image number 2 shows Earth crystals with no polarization. As you can see, the crystals grown on Earth tend to form a bond. Image number 3 shows the microgravity crystals at half polarization, and image number 4 is of the microgravity crystals with no polarization. Just by looking at these images, you can see the microgravity crystals branch out more than those grown on Earth. In fact, during analysis, we struggled to determine whether or not the microgravity crystals were completely bonded because during observation, they were still mobile. Next slide, please.
Pictured here are some of the crystals grown in microgravity. As you can see, the aggregates are very box-like. This formation is unique only to those crystals grown in microgravity. Next slide, please.
In conclusion, microgravity affected the way in which the crystals bonded. The ground truth crystals appeared to be in clumps of smaller crystal and were attracted and seemed completely bonded. The microgravity aggregates were more extended and branched out instead of clumping. They also appeared to lack the bonding displayed by the ground truth crystal growth. Next slide, please.
Our experiment was just an initial step in exploring kidney stone formation in space. Now that we know that microgravity does have an effect on the overall structure, additional questions are raised. What effect does this modified structure have on kidney stone growth? Does the lack of bonding increase or decrease one's chances of developing stones? Additional research in this area will be needed to answer such questions as we explore the concerns of future space travelers. Next slide, please.
We are very grateful for the support of the following organizations and individuals, especially NASA Nebraska Space Grant, Dr. Frank Kovacs, and everyone at the National Center for Earth and Space Science Education. Thank you.
Those look like very, very interesting results. Congratulations. Do we have any questions for the Pleasanton and Callaway, Nebraska team?
Hi, Mary from Rochester, New York. I think your research is fascinating, and as someone who has experienced the pain of kidney stones, I can see how that would be a problem. So in your research and in your background in deciding to do this, what is the incidence, the rate of kidney stones in the astronauts, and did your research tell you anything about, what do they do for those poor people if they get kidney stones in space?
That is a very good question, and I'm unable to answer that right now. More research is still needing to be done in that background, so I'm very sorry that I can't answer that question, but thank you very much.
Other questions? All right, let's thank the Pleasanton, Callaway, Nebraska team.